In this video, we're going to show you how to create the decorative rosette you can see on the screen. I'm going to start with a set of vectors that have been pre-drawn and construct two simple components from those to represent the basic 3D shape. I'm going to calculate a rough and finished toolpath to replicate those, and then to add the detail onto this, the decoration that you can see there that represents the flower. We're going to use a set of vectors and V-carve those vectors, but rather than just cut that on a normal flat surface, we're actually going to use an option within the software to project them onto the 3D model, so that V-carving toolpath will actually follow the contours of the 3D objects that we have within the part. So let's begin by starting a new copy of the software. So let's click on the option to open an existing file, and from the project folder we're going to choose the Aspire file called rosetteVectors.crv3d and hit open. I'm going to go up to View, tile the windows vertical so we can see both the 2D and 3D view, and we'll start by modelling our simple 3D shapes. I'm going to come down, click on the Modelling tab, I'm going to come up and select the 2-rail sweep icon. I'm going to click to select the outer circle, and then holding the Shift key down, I'm going to click with the mouse and select the inner circle. We'll go up and click on the button that says Use Selection in order to choose those two as our rails. Then I'm going to come down, and from the 2D view I'm going to click to select this vector here, which will represent the cross section we're going to sweep around our two circles. And from within the form itself, I'm going to make sure Scale Cross Section with Width is unchecked, and that Fill Center of Inner Closed Vector Rails is checked. So make sure this last one is checked here. I'm going to make sure Combine Mode is set to Add, which is the first option, and we'll give this a name, Main Shape, and hit Apply. Now we can see that shape has been constructed in our 3D view. We have a preview in our 2D view. If we go ahead and hit Close on the form, now you can see in the 2D view that our grayscale preview is obscuring a lot of the vectors in the design. And if we take a look at the layer manager, we can see that's because our currently selected layer is the last one in the list here, 2-rail sweep, and so when we created the shape, that's where the grayscale preview was put. If we want to be able to see the other vectors, I can select this, right mouse click, and just say Move to Layer. We can move it to the first layer in our list, and now when that's deselected, we can see all the vectors that are on the same layer as that object, plus the vectors that are on the layers below it. Let's click on Main Shape in order to make that our active layer, so that any other shapes we create will have the grayscale previews put onto the first layer in the list and won't obscure anything else. Let's come back to the Modelling tab. I'm going to select this circle here, and we'll click on the icon to create shape from vectors. Within this form, I'm going to set my angle to 80, make sure I have the round profile selected here. I'm going to enter a base height of 0.05 and choose the option to scale to exact height and enter a value of 0.35 of an inch. Again, my combine mode, I'm going to make sure that's set to Add, the first option here, and we'll call this Middle. Go ahead and hit Apply, and there you can see we've created our shape. We can close. And at this point we've actually got all the 3D data we need to start calculating our toolpaths. So before we go across to the Toolpaths tab, let's just tidy up our layers so we can more easily see what's going on in the 2D view. I'm going to click on the Layers tab. I'm going to come up and I'm going to undraw the 2-rail sweep layer. So I'm going to click on the light bulb. You can see the cross section and the small circle have disappeared. We still have this circle that we use to model the middle shape here, and I'd also like to put that on an invisible layer. So with that selected, I'm going to right mouse click, move to layer, and also choose the 2-rail sweep layer. Now we can see that's disappeared as well. So at this point I'm ready to go over to the Toolpaths tab. I'm going to click on the Drawing tab here, come up and click on the icon to switch to Toolpaths tab, and we'll see that the Design tabs have now been hidden on the left, Toolpaths tab's been opened on the right. Now first I want to calculate my rough and finished toolpaths for my 3D, but as with any job, before we calculate toolpaths, what we want to do is double check our material setup. So let's come across and click on the set button here. We have the material thickness set to 3/4 of an inch. Datum is in the lower left corner, which is good. I'm going to set my gap above to be 0.05 of an inch and just double check my rapid Z gaps and home start position. If they all look okay, then we can click the button there in order to accept those values. As with any job where we're calculating toolpaths within the demonstration, if you're planning to cut it, you need to make sure that the values you choose for the material setup and for all the toolpaths and tooling are appropriate to your CNC, the material you're planning to use and the tools you have available. Next, I'm going to select the circle that surrounds our part and use that as a boundary to calculate my rough and finish toolpaths. Let's come across and click on the 3D roughing toolpath icon. And in this case, because our part doesn't have much detail, I'm actually going to use the same tool to do both the roughing and the finishing toolpaths. Let's come up and click on the select button, and from the tool database I'm going to select the ball nose 0.25 inch and hit OK. And then for the purposes of this toolpath, I'd like to make a couple of changes to that tool's parameters. So I'm going to click on the edit button. For the pass depth, I'm going to increase this a little to 0.18. And then for the step over, I'm going to change this to 40%. In this case, we're hogging out the material, so I don't want to finish step over. I'd like to speed it up. So with those values changed, I can hit OK. I'm going to set the machining allowance to 0.03. Going to do Z-level roughing, raster X, profile last, and enter a boundary vector offset of 0.18, which is enough space for the tool radius and the machining allowance to allow the tool to roll over down the side of the part. Let's just change the name, give it something appropriate, hit calculate, and there we can see our toolpath within the 3D view. If we go to an ISO view, we can come and click on the button to preview selected toolpath and see the result of the choices we just made. If we're happy with the way that looks, we can hit close on the preview toolpath form and we're ready to do our finishing. Again, make sure that vector is still selected. Click on the icon here for 3D finishing toolpath. We're going to select the same tool here, so ball nose 0.25 inch from the tool database, hit OK. Going to do an offset strategy following the circular shape, and I'm going to set in here a value that's large enough to allow the tool to fit down the side of the object, so I'll enter 0.15. Give the toolpath an appropriate name and hit calculate. We'll see once that's calculated, the software puts us over automatically into the preview toolpath form. With that toolpath selected, we can click on the button to preview selected toolpath. This will just take a few seconds for the software to go ahead and make the calculation to animate that toolpath within our virtual block of material. And now we should see that update, and we can make sure that the part looks okay. We're happy with the finish, even though we've used that reasonably large tool in this case. If we are, we can hit close on the preview toolpath form. And now we're ready to calculate the toolpath that will add the decoration to our rosette. Let's come over to the 2D view and carefully click and drag a box that just contains the vectors on the inside of the job. You'll notice that that selected the vectors but also selected the component preview in the middle, so I'm just going to hold down Shift and click on that to deselect it. I just want to have these vectors in my selection. I'm going to come over to the Toolpaths tab and click on the V-Carve icon. Within here I'm going to set a start depth of 0, and I'm going to click the select button, and from the tool database under V-bits I'm going to choose the 60 degree 0.25 inch tool, fairly sharp V-bit tool. We'll just take the default values and hit OK. Not going to change anything else in the form for the moment. I'm just going to come down, we'll adjust the name there and click on the calculate button. Now if we look at the toolpath we've calculated, we told it our start depth was 0, so it will have started on the surface of the part, in effect the surface of our block. So if we spin this around, we can see that if we look from the side, everything is straight across the top of the part. Now in this case that's not going to work for us because our part actually has some contour to it so that it's flowing down into the job here. So what we actually want to do when we calculate this toolpath is check one more option. If I select this and we just close the preview, come up and click on the icon to edit that toolpath, at the very bottom of the form we have the option here to project toolpath onto 3D model. By checking that, it's going to take all the values we've entered above, but now just apply it onto the surface of our part and get it to follow whatever shape is visible in the 3D view. So with that checked, I'm just going to hit calculate. That'll recalculate that same toolpath, and now if we look down the x-axis we can see how that slopes into the job and is flowing along the surface of our 3D object. If we want to double check that, of course, we've come into the preview toolpath form, make sure that toolpath selected and click on the button to preview selected toolpath, and there we can see how that V-carve toolpath is going to be machined into the 3D job following the shape that we've got there in the 3D view. So to finish this particular part off, we can hit close on the preview toolpath form, select the outer circular vector again, come up and click on the profile toolpath option, make sure our cut depth is set to an appropriate value to cut through the material. I'm going to hit select, choose a regular flat end mill, and then we'll just make sure machine vectors is set for outside. Just take the defaults for this, we'll assume we have a way to hold it down without using tabs. Calculate that, preview it, and then we can double click on the material on the outside, maximize the 3D view, and now we can actually see our 3D part and how that toolpath that we chose, the V-carving, once projected onto the 3D model, created the decoration exactly as we wanted it to in relation to the 3D shape that was underneath it. Project toolpath onto 3D model is available for most of the 2D and 2.5D toolpath functions within Aspire. There is one thing to note when using this option though, and that's that the software is projecting the center of the tool onto the 3D part and not gouge checking the complete shape of the tool. As such, you are limited to projecting onto shapes that don't have sudden transitions of depth or have very high angles on them. The result of this toolpath will be accurately shown in the 3D preview though, so just make sure to use that in order to check what the result of this is going to look like before you machine it. At this point, let's go ahead, click on File, Save As. We'll save this as rosette-tp.crv3d, hit the Save button. Just replace the one that's there, and if you wanted to, you can load that file from the project folder in order to take a look at this. So that concludes this particular example where we constructed this rosette and went ahead and showed you how to create the toolpaths, including using the option to project onto the 3D model so that we could get our V-carve toolpath to follow the contour of the components underneath. There is another video where we show the project toolpath option used to project distorted text onto the pages of a three-dimensional model of a book. So if you're interested in this technique, you may also want to review that particular video.